Hello, this is Hyunsu Moon at Data Network Laboratory, Chungnam National University. Now, I will be talking about the paper titled RDBMS-based Bitcoin Analysis Method. As of 1,000 cryptocurrencies, including Bitcoin and Ethereum, have been popular in the market across the world. The cryptocurrency market is growing to more than $400 billion, even considering only Bitcoin and Ethereum. Blockchain-based cryptocurrency guarantees anonymity, so it is difficult to monitor or analyze. The cryptocurrency has anonymity, and because of this, it is used in deep web, where illegal products such as drugs and weapons are traded. Look at the picture below. As you see, it is a screenshot of a deep web selling a drug for Bitcoin. We can find these services easily. To limit these cryptocurrency trades and detect abnormal transactions, many government agencies are demanding methods for tracking and analyzing Bitcoin trades increasingly. Before dealing with the main idea, let's look at the result of our method. We can analyze the Bitcoin, which has the largest market size, just using one line of code. For example, it supports queries about increasing or decreasing of the balance of the address for a specific period, Bitcoin address heuristic, and address transaction graph. Let's look at the example of the one-line Bitcoin analysis. Using our method, we can calculate changes in balance of address in the specific period. This convenience ensures an easy interface of analytics and makes other tools compatible. In this paper, we propose an extensible and scalable Bitcoin analysis based on RDBMS. We use the RDBMS for solving three big key challenges. The Bitcoin blockchain data has very big size itself, and it gets much bigger when it converts into string format, which users can read. So, scalable Bitcoin data ingestion and storage must be needed. Second, Bitcoin analysis often need plain questions that can be expressed with a user-friendly interface for the data analyzers. For this purpose, we should build transaction information and related metadata. Last, Bitcoin analysis required integration with the related software, such as Bitcoin Core, data storage, visualization, and web servers. Of course, many tools for analyzing Bitcoin are developed previously, with growing use of Bitcoin and needs of its analysis. They can be represented for BlockSCI, which has fastest analysis speed, using append-only data structure, and GraphSense, which executes graph analysis based on BlockSCI. There are more tools, such as BTC Spark, that support distributed analysis for Bitcoin in the cluster based on Spark, and Bitcoin Aave, which can be analyzed via web interfaces. However, we focused on the quick analysis of Bitcoin with only SQL, without any dependencies. For the RDBMS-based Bitcoin analysis, we designed a Bitcoin data collector that ingests Bitcoin information from Bitcoin Core, like this figure. The Bitcoin data collector imports transaction data through JSON RPC, encode address tag data from web, such as Wallet Explorer. We store the Bitcoin data in the SQLite 3 consists of 3 databases and 7 data tables for scalability. Although Bitcoin Core provides transaction data on the blockchain, it will take a long time to retrieve addresses or transactions for the given time period or a specific cluster. In order to minimize the access time to transactions across the long blockchain, we create the tables. We present 3-layer databases of index, core, and utility. Index database has key identifier tables for blocks, transactions, and addresses with the integer type. The index database is used for reducing the long Bitcoin hash value to the integer variable, so we can decrease the size of Bitcoin core tables by 65%. The core database maintains the transaction information tables through JSON RPC by iterating all transactions along the blockchain. Due to the core database, we can improve the response time of transaction analysis, including specific address for input or output and clustering heuristics. We also retain the utility database for the fast response time of joining tables. Utility database save query results that can be obtained only with index and core databases. Its response speed is improved by eliminating repeated join operation. It is especially used for extracting address transaction graph. We will provide 3 analyses in broad categories. First is the analysis of basic information on the Bitcoin blockchain. We can easily retrieve Bitcoin address, transaction, and cluster information with data, time, and clusters conditions. For example, if a user wants to analyze transactions and addresses generated during a specific period, by using this analysis method, the query can be analyzed as a conditional statement. Second, our method supports cluster analysis, such as finding the owner of a Bitcoin address or finding a list of addresses of that owner. A Bitcoin cluster is defined as a set of addresses belonging to a single organization, such as a cryptocurrency exchange. To find a Bitcoin cluster, we need to group a set of addresses for a specific cluster. In our analysis method, we implemented representative Bitcoin address clustering heuristics. The most representative heuristic is the multi-input heuristic, which groups the input address for single transaction. After applying the address clustering step, we put appropriate tags to the cluster by using the crowdsourcing address tag data. As Bitcoin addresses and transactions can be modeled as a graph, our method supports graph-based analysis. We can calculate the degree of an address node with simple query. In addition, edge information that can generate a graph can be output as a CSV file for complex graph algorithms such as PageRank and community detection. We can also extract a subgraph with conditions such as duration, block height, address tag, or cluster. In this paper, we presented solutions for 7 problems using our method. It showed that our method can be used in analysis well. The problems are like finding the most important address, finding the cluster, analyzing the cluster characteristics, and analyzing the graph. We used all the data from the Genesis block of the Bitcoin blockchain to block height 744806. The database construction took about 4 hours, with 560 million transactions and 704 million addresses added to the database. The first question: which address has the largest amount of Bitcoin? As Bitcoin is based on unspent transaction output, called UTXO, we must add all the UTXO BTC values of the address to find the balance of specific addresses. Bitcoin is generated every time a block is mined, and 18 million BTC has been generated as of August 2020. And 71 million addresses hold this Bitcoin. Among them, the address with the most Bitcoin consists of 355 UTXOs and has 1.14% of generated Bitcoins. According to crowdsourcing data, this address is known as the cold wallet of an exchange called Huobi.com. The second analysis, clustering Bitcoin addresses with heuristic. We have performed a multi-input heuristic and one-time change heuristic for all Bitcoin transactions. With multi-input heuristics, we processed 691 million addresses and grouped 418 million addresses into 61 million clusters. We observed that 90% of clusters are small, with less than 10 addresses. Next, we clustered the Bitcoin addresses using both the multi-input heuristic and one-time change heuristics. Compared to using only multi-input heuristics, we clustered 45 million addresses more by using both heuristics. But unfortunately, a supercluster which has 177 million addresses was created too. For third analysis, we identify clusters with address tag information. After applying the Bitcoin address clustering heuristic, we identify the owner of the cluster through Bitcoin address tag information. We collected address tag information in the website such as Wallet Explorer. Result of applying address tag data, 86 million addresses were identified. Exchange, ransomware, payment service are largest cluster in these clusters. The first question: what is the amount and count of transactions to CryptoRocker addresses? Ransomware victims usually pay to the attackers using Bitcoin. Therefore, in order to analyze the amount of ransomware fee, it is necessary to investigate Bitcoin transactions transferred to the ransomware cluster. According to Wikipedia and news reports, CryptoRocker has broken out and continued until May 2014. However, we observed that no transaction has occurred since February 2014, which is earlier than the closure. 2,700 BTC was transferred so far, and most transactions occurred in October 2013. It means that crypto rock spread most at the time. Cryptocurrency exchange operator not only exchange real and virtual currencies, but also issue Bitcoin addresses for customers and perform transactions on behalf of customers. In general, for this purpose, exchange use three types of wallet addresses. A user wallet that is distributed users. A hot wallet used to collect cryptocurrencies deposited of users' addresses and to send cryptocurrency to outside the exchange. A cold wallet that stores cryptocurrency for storage and security. Among them, the core address of the exchange operation is the hot wallet. We use the high in degree or out degree of the address node for finding exchanges hot wallets. We observe that 12 of 3,000 addresses of exchange A have a degree of more than 1,000. Bitcoin blockchain can be represented as a graph because the input address and the output address are connected with a transaction. After building a graph with Bitcoin address node and transaction edges, we perform PageRank algorithm to Silkroad black market graph for finding most important addresses. Silkroad is famous black market from 2011 to 2013. As the PageRank algorithm can reveal the importance of node in weighted graph, we employ this algorithm in iGraph, which is a graphical analysis library. After finding the most important address of the Silkroad cluster with the PageRank algorithm, we look at the transaction change of the address over time. After Silkroad was arrested by the FBI in 2013, its operation was stopped. However, we can observe that the transaction occurred recently. The Bitcoin address heuristic using the characteristics of the Bitcoin owners causes inaccuracies due to coin join and mixing services. In order to compensate for these shortcomings, a community detection algorithm can be used. We built Bitcoin address transaction graph of Korean exchange B and found clusters with the latent community detection algorithm. We can observe that the largest community was a cluster of 51,000 out of 275,000 addresses. In this paper, we propose Bitcoin analysis based on RDBMS. Our RDBMS-based analysis method supports Bitcoin analytics, cluster analytics, and graph analytics. As you see, 7 problems can be solved through our method. We plan to build an RDBMS-based Bitcoin analysis system. This is the end of the presentation. Thank you for your attention.
Thanks for presentation, Moon. If any questions, really? I guess there are 2 questions yet.
Okay. First question is Taeung. Taeung asked me why we use the RDMS, right? Of course, there are many software that use other databases. They often store blockchains in Apache Cassandra or MongoDB, right? Like the NoSQL. However, we think that this data structure or database is useful to only developers, but are too difficult to many analysts. In addition, SQL-based analysis is more useful because it can be easily integrated with other analysis software, especially web services. Okay. And next question is J.H. Bark asked me SQLite. Yes, so other RDBMS, yes, it's, of course, we can use other RDBMS database software.
Thanks for answers.
For
So
Bitcoin
yeah.
addressing is it's I think it's not a problem we solved in this paper. So it seems to be solved in other ways like crowdsourcing or etc. Third question from the team.
Okay, thanks for answer. Then I'll give it a small question.
Okay.
So I wonder about how to identify the credibility of this research, including some information, because you said you gathered some information from the internet. So yeah.
We just assume that this data is true because it is some of crowdsourcing data. So it's we just assume.
Okay, thanks. Yeah, thanks for presentation. Yeah.